Welcome to this topic, machine learning in Julia. So machine learning is a hot topic, and I think one of the objective is for you to come here and watch these tutorials is basically to learn about the machine learning. So we will see how we can do the machine learning and do some predictions, right? So let's go ahead and start doing this without any further delay. So using pkg, because we need to add a package for machine learning. So pkg.add, and the package that we want to add is scikit-learn. So I have already added this, but go ahead and add this, because for me, if I run it, it will take a minute or two, but just update the libraries for me. So once you are done with this and you have properly installed everything, what you need to do is you need to import using scikit-learn and or over here CSV. So we want to import, or we want to use these two packages, because CSV is to get the CSV file that we imported earlier, the iris file on which we can apply the machine learning algorithms for classification problems, and scikit-learn provides those classification algorithms. Alright, so without further delay, let's get the data set iris equals to csv.read, and within that iris.csv we want to normalize the name. So normalize names equals to true, and once we do that, we will get the iris in a couple of seconds, and it will show us the data set and some of the sampled rows from the iris. So I'm still waiting for it, and we'll take, yeah, there it is, sepal length, sepal width, petal length, petal width, and species. So based on these four numerical variables, we want to predict the species, whether based on these four parameters, whether it is setosa, there is three different, one versicolor, and there is one more to it. So out of those three, which one it is based on these four parameters. All right. So to do that, one thing is that these machine learning libraries only take arrays into it as an x and y parameter, or dependent or independent values. So what I'm going to do is, first of all, define iris_x and call it convert function. Within that, I want to specify that I want to convert an array of iris where I want to take all the rows, but only first, second, third, and fourth column. So what is going on here is I want to take, so these are my dependent parameters which I want to use, based on which I want to use the prediction, and this is my independent or the target variable which I want to predict. So these four are basically the values for x, x1, x2, x3, x4, think like this. So once we do that, it will going to execute and convert it into an array, gives the warning, ignore it, and let me just do it one more time because I don't want to print off the numbers. So iris_y, same method, convert array iris, all the rows but fifth column only. All right. So once we do that, it will give us the target variable that we need for the machine learning algorithm. Now I need to import the machine learning algorithm. So for that, I use the inbuilt macro, which is sk_import, and from the linear model, I want logistic regression. So just want to make sure the name is correct. Logistic regression. Looks like I'm fine. If I execute, it will import the logistic regression for me. Yeah, gave me no issues. And after that, what I can do is I need to specify the model or log reg model, just to be very, very safe, because there will be multiple models. For example, we will use logistic regression, we will use decision tree, and we will use random forest for this particular video. So you will get in one video everything. So log reg model equals to initialize the model. logistic regression. And once we execute it, this is the initialization of the model into this particular object, and these are the different parameters. So we will just work with the default one and apply it into the fit. So fit exclamation and model name log rag model, and the x value for from the iris, so iris underscore x. So once we execute it, it threw an error. Iris x, iris underscore y, because both of them need to be over there. So now everything is fine. It has given me the output with warning, which I will ignore for now. And after that, what I can do is prediction. So predictions equals to predict method, and I need to specify the log rag. The log rag model. Yeah, that's where I created the model out of this. So it is preserving all the processing, and now I need to provide the iris underscore x. That means the x value from which it will going to predict, right? Because from these 4 values only it can predict what type of species a flower is. All right. So this is what it is going over here. We are mentioning the model and giving it the 4 different parameters and asking to predict for each row. So once we execute it, the predictions are over here. So it is predicting that first is Setosa, and down there it's Virginica based on the values it has observed into the model. So now let's see the accuracy of the model. So for accuracy of the model, we need to import the accuracy metric, and to import it, it's again pretty simple. @sk underscore import. From the matrix, we want accuracy underscore score. Once we execute it, it is now imported, and now I can say accuracy equals to accuracy underscore score. And first is predictions, that means what have been our predictions, and next is the real values to compare with, which is iris underscore y. So this has predictions which are these, right? These are our predictions that we predicted based on the model, and our real value iris underscore y, which we defined it over here, which is the 5th column, and the 5th column is over here 1, 2, 3, 4, 5. So species is the 5th column. So that means we are doing the right operation. So once we execute it, it gives us that we are 96% accurate with this. So that's a very good accuracy at the very first iteration. But just to keep in mind, this is a sample data set. In real world, you will not find a data set like this, which is so mature or with this, all the functionality which is already present over there. You have to do a lot of work, and then only you can reach to an accuracy of the 96%. But this is mostly from the training or tutorial perspective. That's why I think accuracy is fine. And we can move ahead now with another model, which is tree model. So before that, I need to import the model. So sk underscore import from the tree, get the decision tree classifier. Once we do that, I can now create tree underscore model, and this is nothing but the initialization of the model. Once we initialize it, it shows us what the parameters with which it has been initialized, right? We can change the parameters as well. For example, if we want to change the class weight, criterion, max leaf node, min impurity decreases, it's just that it needs a whole lot of information about what each of these parameters does, and that's like a totally separate long tutorial about decision tree classifier. And that's where, as a real data scientist, your most of the time will go. So for now, we will work with default and fit fit exclamation sign, and within that specify the tree underscore model iris underscore x, iris underscore y. So what we are saying that, hey, go ahead and fit the model on iris x and iris y value based on the tree model. So model and execute it. So it has done the execution of the model, and now let's do the prediction. Tree underscore predictions equals to predict method, provide the model name tree underscore model and the x values based on those 4 parameter value it will predict each and every value. All right, so there is our predictions. So we have now tree predictions. We can now see the tree accuracy, and for that we already have the accuracy score, and within the accuracy score we need to first specify what we are predicting. So that is tree underscore predictions and iris underscore y, which is our target variable. So that is 1.0. That means it is predicting 100%. So it's way better. Decision tree is way better than logistic regression in this case. So that's amazing. Now let's go ahead and import sk.import the random forest method, which is an advanced method than the decision tree. And based on the situation, you basically decide whether you want logistic regression, you want decision tree, or you want random classifier. So let's see random forest classifier, and it is present in the ensemble. So, and from the ensemble, get the random forest classifier. Error, it is giving me an error that from the ensemble it could not find the random forest classifier. So ENSEM, okay, ENSEMBL, that's the right name. Now, yeah, now it's done. Okay, so let's go ahead and initialize the model RF, which is nothing but random forest model, and we will just initialize it. So random forest classifier. So after initialization, it is giving us the default parameters with which it has been initialized the model, RF underscore model. And as I said earlier, we can always change the values of these parameters, which is nothing but the hyperparameter tuning, a separate subject altogether for these algorithms. All right, so we want to fit the model. So RF underscore model on iris underscore x and iris underscore y. Once we fit it, this is basically now stored. Output is stored into this. Now we need to do the prediction, the same steps. So RF underscore prediction, so that I am not overwriting the other previous prediction parameters or the objects that I created. Predictions are here, and the method is predict on the RF model. That's where the model output is, and the values are in iris underscore x, and this is where our predictions are. Okay, and now I need to check the accuracy of random forest. It should be very similar to decision tree, because random forest is an advanced version of the decision tree classifier. So it should be 100% or near about that, what I expect. Okay, so for that, accuracy underscore score prediction RF underscore prediction and iris underscore y, the real value against which we want to predict that how well predictions are matching up with the iris target value. So that's 99.33. That means 99.33% is the accuracy level. That means almost 100%. And as I said earlier, it is very similar. It has to be very similar to the decision tree. It's just that in this case, decision trees are working way much better than the random forest, and the random forest is an advanced version. So sometimes it doesn't really mean that you are using an advanced algorithm, then you will get the right output. Sometimes choosing the right algorithm for the right type of data is necessary, and that's why data scientists experiment with the different types of algorithm by changing their different parameters, which I mentioned to you, which we are working right now based on the default settings. All right, one last piece I want is basically the train test data. So right now what we have been doing is picking up the entire data, the entire iris X and iris Y, and the drawback is that we are not testing our data or our model on the real value, and that's not the condition, or that's not the situation you will face. So once you have created a model, you will always see an issue having it with the real data, the real world new data. So for that, most of the time what data scientists usually do is create a train test data, so that there is a data set for training and there is a data set for testing. So let's see how we can do that. So sk_import, we need to import from the model underscore selection, we need to import the train test split method, train test split. All right, once we have imported, we need to define it, and just bear with me, we will going to define 4 variables here: x train, x test, y train, and y test, because we need train and test value. And now I will going to use train test underscore split, and I will use iris underscore x for the x values, because first the x values are coming, train and test, iris underscore y. And we can use something like test underscore size to specify we want 60% split, 70% split. But if I don't specify this, the data set, the iris underscore x and y, will be split into 75% and 25%. That means the 75% will go, the 75% of the value will go on the train, x train and y train, and 25% for validation will go in x test and y test. So I will just leave it default, but if you want to change it 75% value, you can have the test size equals to 0.6, which is 60%. So another variable, parameter is random underscore state equals to 1, so that whatever I am doing over here, you will also see the same result. So once I execute it, it will execute the value for you, and yeah, that's the output. And now what we can do is log reg 2, because we created a logistic regression earlier. So let's run the logistic regression again, initialize this, fit log underscore reg 2 equals to, log reg 2 and x underscore train and y underscore train. So we are working with the training data. All right, fit not defined. All right, what is that? So this is over here, log underscore reg underscore 2. Okay, so now we are good. It has given us the output, so we are fine. Now let's do the prediction underscore log underscore reg, and the method is predict log underscore reg x underscore test, because we have fit the model on the training data. Now the testing will be done on the test data. So x underscore test underscore, I don't know why I added another underscore, but let me add it here if I've done that earlier. Log reg 2. Okay, so here now we have our predictions over here, and now we can do the testing, like accuracy. What is our accuracy score? So accuracy underscore log underscore reg and accuracy underscore score, and within that we have predictions, and we need to do it on the unseen data. So y underscore test is the test or validation data which our model has not seen yet, and this will tell us the real picture of our predictions, and you will see that how different it is than the earlier prediction output, which was 96% if you remember. So once I execute, it has given me the error. So y_test, is there anything which I have mentioned differently? xy_test is fine. So something I have not, predictions _log_rag. Yeah, that's it, log_rag. And this is 84% accuracy. So from 96% you dropped to 84% with the existing data itself. So that means, you know, how you can see how important it is in the real world to train your data first of all and show it or test it against the unseen data. So many times unseen data is not available. That's why you basically split the entire data into test and train. And with that, you can really identify how well your model will going to work in the real condition. Now you have got the 84% accuracy, which is a 12% drop, and it's a significant drop. So what you can do is then, next thing is, first of all, test the different models. So test it with the decision tree. I have already shown you the method for logistic regression, the same steps you need to do for the decision tree classifier as well as the random forest methods, and then see what is the value that you are getting. Once you are getting a better value, you will get to know that which method is or which algorithm is working fine. And after that, there are a couple of other things which can be done, and I have not covered it here because that requires me to create a separate tutorial itself, which is again a long series that I may probably plan in the future. And that is having the cross validations and randomized search CV and hyperparameter tunings that we have discussed over here. These parameters, how we can really tune these parameters so that it is giving us the better output. Right now we are just working with the default as we are starting with the machine learning within the Julia. So that's about it that I have for you in this video for the machine learning, for the prediction and checking the accuracy. And probably I'll meet you in the next video.